Okay, so we're going to, again, clarify what you went over on Friday with the mole. And just as kind of a summary for it, okay, the mole is just a way for us to actually count atoms. That's why it was originally developed. The mole is simply a name assigned to represent a specific number. Just like if I were to tell you to go get me a dozen of something, how many would you get me? 12. If I say I need a couple of something, how many do I need? 2. The mole is the same type of situation. If I need a mole of something, I need, do you remember the number?
602 somethings.
The 6 number, the 6.02 times 10 to the 23rd, which, remember, atoms are really small. So we need a really big number to kind of encompass them. So the real number is over on the board. That's what it really looks like. And I really liked what this slide had to say in your video from Friday. I thought it did a really good summary. It's just whether or not you chose to actually read what you were writing at the time. So the mass of 1 mole of an element is your molar mass of that element. And it's defined in terms of the element's atomic mass. Where are you going to find atomic mass? Yep. Periodic table. Everybody pointed to it. Periodic table is where you're going to find atomic mass. So when they say that carbon's atomic mass is the 12.010 number, they're finding that on the periodic table. And so that means that carbon's molar mass is that same number in grams. So 1 mole of carbon has a mass of 12.0107 grams. So 12.0107 grams is equal to 6.02 times 10 to the 23rd atoms. That's how much that many atoms weighs. So, if we look at this in terms of something else, so let's say I have this, 1 mole of nitrogen. If I know that I have 1 mole of nitrogen, how many atoms of nitrogen must I have? 6.02 times 10 to the 23rd. Because it's just like I asked you for a dozen. I told you I have a mole. This is how many a mole is. So there you go. If I have 1 mole of nitrogen, that's how many atoms I have. Okay, now could you fill in that blank? What is the mass of 1 mole of nitrogen? A what? Look up at the periodic table. Okay, what label does it need?
Grams per mole.
Okay, grams is the mass of 1 mole. If I'm asking for molar mass, which that was a good thing for you to say, that unit. If I'm asking for molar mass of nitrogen, then it's 14.007 grams per mole. Very good. So on this slide, it tells you that they have 1 mole of carbon dioxide. And then it asks specific questions about that 1 mole. How many moles of carbon are there? Well, how many atoms are in that compound right there? Total, there's 3. How many carbon atoms? 1 carbon atom, so there's 1 mole of carbon in that molecule. Make sense? So that means there's double the moles of oxygen in it, so there's 2 moles of oxygen in that molecule. Then it says how many molecules of carbon dioxide, that whole thing. And it tells you have 1 mole. 1 mole is always 6.02 times 10 to the 23rd. Now, as far as atoms of carbon, we already said right up here that we have 1 mole of carbon. So again, we have the 6.02 times 10 to the 23rd atoms. Then it says atoms of oxygen. Right up here, it said that we had 2 moles of oxygen within that molecule. So we had to take our 6.02 times 10 to the 23rd times 2 to give us the 1.2 times 10 to the 24th. Okay? So let's try a different example. Okay? I have 1 mole of water. That is the fact. How many moles of hydrogen do I have? 2. Very good. How many moles of oxygen do I have? 1. How many molecules of water? How many?
6.02 times 10 to the 23rd.
Why'd you say that?
Because 1 mole is that.
Because 1 mole is that. If I have 1 mole of water, I have that many molecules of it. Very good. Okay. Always look to moles to find atoms. How many atoms of oxygen?
6.02.
Good. Like I said, look to moles to find atoms. That's how many moles we had, so that tells you how many atoms. How many atoms of hydrogen?
204 10 to the 24th.
Said 1.2 times 10 to the 24th. What did you do to get that number?
2 times 6.02 times 10 to the 23rd.
2 times 6.02 times 10 to the 23rd to give you your atoms of hydrogen. Okay, so now, using molar masses of individual elements, which we already practiced, we found it on the periodic table, we can find the molar mass or mass of 1 mole of compounds as well. The example that we're going to use today, or for right now, I guess I should say, for right now, is barium sulfate. And the first thing that you want to ask yourself is how many moles of each atom are there? So here I've listed all of the elements that are present. How many moles of barium are in that compound? Just the 1? What about sulfur?
1.
Okay. How about oxygen?
4.
4. Okay, that's step 1. Second question you ask yourself. How much does each mole weigh in grams? So how much does 1 mole of barium weigh? 137.33. Periodic table. Okay. How much does 1 mole of sulfur weigh? 32.06. How about oxygen? 15.999. Now, to get the overall molar mass of the compound, we know that we only had 1 barium, so we're only going to take that mass times 1, because there's only 1 of them. For sulfur, we had 1 of them as well, so we only take that times 1. But for oxygen, we had 4 of them, so we have to take that mass times 4. If you add all of those together, that's everything within that compound, and that's how much the total compound is going to weigh. What I got when I did this math is this right here. Is that what you guys got? Okay. And I need to include my label here. And this is molar mass, so is it just grams? Grams per mole. That is the molar mass of barium sulfate. So this number right here is actually the mass of how many formula units of barium sulfate. How many barium sulfates are there to equal that mass? Our label right here says that's the mass in grams of 1 mole, right? 1 mole of anything is how many? So this right here is the mass of 6.02 times 10 to the 23rd formula units of barium. So go ahead and try this on your own. And I'll take a couple minutes, then we'll go back through it together, and then I'll give you another one. As far as these go, there are 2 ways to think about them. I'll go through them both. Okay. The number of atoms in 2.50 moles of zinc. Do we know how many atoms are in 1 mole of zinc? How many? And if we have 2.5 moles, don't we just need to take 2.5 times that number? Yes, that's one way to think about it. And you can do that. And in that case, the answer I got was and your label would be atoms. The other thing that you can do, which this is how I do them just because it's good to get into the habit, but truth be told, I don't care how you do them as long as you're doing them, you can show work and you're doing them correctly. This is just good to get into the habit of it because this is the method that you're going to be using for stoichiometry, which is where we're heading. So, for that, I have 2.50 moles of zinc. And I can use the conversion factor for that. I know that 1 mole of zinc, just like I put at the beginning of our last little bit of math, is equal to 6.02 times 10 to the 23rd atoms. Those cancel out. I still end up multiplying, don't I? So that's another way that you can do it. And like I said, it's good to get into this habit because you'll be doing longer strings of these as we go. Try that practice problem on your own. Okay, you guys have an answer? Yes? Okay? I'm just going to show you what I got, and if you have an issue, we'll talk about it. Otherwise, we'll move on. How many of you got that answer? Okay. All you had to do was take 3.25 times what number? 6.02 times 10 to the 23rd. Okay. A little different type of practice problem there. But give it a try on your own, and then we'll see how you do. So again, this right here is the key to the problem. And if I know that I have 5.75 times 10 to the 24th atoms, and I know that 1 mole is equal to this many atoms, can't I just take this number divided by my 6.02 times 10 to the 23rd? Give me my answer? Yes, you can. Also, you can set up your conversion factor like I did before to make sure that you're doing it right, because you know if your units cancel, then you're in good shape. So my atoms cancel, and I'm left with moles, and the answer that I got was 9.55 moles. Okay, so now tell me how many moles of carbon dioxide I have if I have that many molecules. Now, to just confirm that we're doing okay with molar mass, we're going to do some molar mass problems. Because you're going to use molar mass and all of this stuff for the rest of the time. Molar mass is extremely important to get correct answers in the future. So, first of all, what is the molar mass of this? Okay, so get that right off the periodic table. Make sure you label it in grams per mole because it's molar mass. Now try this one. All right, I'm going to show you what I got. Okay, raise your hand if you did get that. Okay. Now, notice how I did not round at all. I do not want you to for molar mass. Always leave it alone. Okay? Okay. Make sure that you correctly determine how many of each atom is in that compound, and then determine the molar mass. Okay, then I'll show you what I got. Okay, raise your hand if you got that.
This is a jam. Get ready for this.
So hopefully that was good clarification for Friday for you if you were having any trouble.
Oh, last Friday.